Hello. Right now we're going to be going through problem number 17 from chapter 3. And for this one there's two vectors, A and B, in the figure. They have equal magnitudes of 10 meters. And we are given an angle, so theta 1 equals 30 degrees. So we can write that in right here, 30 degrees. And then theta 2 equals 105 degrees, right there. And we're supposed to find the x and y components of the vector sum r, and the magnitude of r, and the angle that r makes with a positive direction on the x-axis. So first, what we can do is we can draw our vector r, and so we can kind of have an idea of what we're aiming towards. And remember, if you line your vectors up from end to end like this, then the sum is going to be going from the first end to this point right here. So here is r. And that's a good idea, so that when you get the magnitude and the angle and all of that, you can verify with yourself that it looks relatively like it should. So next is I'm going to break things down into the x and y components. And so first I will use A. And so in the x direction, we know that it has a magnitude of 10 and an angle of 30. So in the x direction, we have 10 times cosine of 30 degrees, and this will equal 8.66 meters. And then in the y direction is very similar, but we're going to use sine. So 10 times sine of 30 degrees, and this will equal 5 meters. And so this is just breaking this down to the x of 8.66 and the y of 5. And so now we need to do the same thing for vector B. However, for this one, it's not as simple as just using 105 degrees, because we see that this 105 is with respect to our first vector, not with respect to the x-axis. And so we want to figure out what the angle is with our x-axis. And so I will draw, there's a horizontal line right there, and we see that this 30 degrees is a corresponding angle to this one right here. So this is also 30 degrees. Which means that that entire angle to the horizontal is going to be 135 degrees. And now that I know that, I can again just use sine and cosine to figure out the magnitude of the x and the y components. So for x, again, the magnitude of our vector is 10, so I'll have 10 cosine 135. It's also another choice. You could have just used this angle over here, 45 degrees, to figure out the components. But of course that would have not given you the negatives that are present there. So as long as you're aware of those and include those in your answer, that's no problem. But I'm just going to use 135, and that's going to give me the magnitude and the direction of my vector. So 10 times cosine of 135 is going to be negative 7.07 meters. And then for the y direction, we again have 10 times sine of 135, and that will equal positive 7.07 meters. And so now I've broken all of them down into the x and y components, and I want to figure out the x and y component together. And so I'm going to take the x component here and combine it with the x component here. And so my x is going to end up being 8.66 minus 7.07, and that equals 1.59 meters. So this is the answer for part A. And then for my y components, that's going to be 5 meters plus 7.07 meters, and so we can see that that is going to be 12.07 meters. So this is the answer to part B. And so next what we want to do is figure out the magnitude. I'm going to go on to the next screen because we're getting a little bit crowded right here. But we'll need to remember that so far in unit vector notation, we have 1.59 meters I hat plus 12.07 meters j hat. And if we were looking at that image again, this is our r right here again. That does look like it's a little bit over, so like 1 point something, and then a lot more up, so 12 point something. So that seems to be the right answer, but let's keep working. So then the magnitude of r, we're just gonna use the Pythagorean theorem, and so I have 1.59 squared plus 12.07 squared, and take the square root of the whole thing, which will equal 12.17 meters. And then for the angle, we just want to take the tangent of it, so the arc tangent of our y over our x, and this will give us our angle of 82 degrees, which is what it looks like. It's a large angle because it's all the way up to there, and so indeed that is the right answer.